Look at this. The length of a rectangle is 3 more than twice its width. The area is 90 square centimeters. What is the perimeter? When staring at a paragraph of text with very few numbers, it's easy to freeze up. We're asked to find a physical shape, but all we have is a block of words. We are going to solve this by starting with basic shapes. Once we've mastered how to manage boundaries and internal spaces, we'll use those rules to solve the algebraic version of this problem. Success in geometry depends on translation. If you can turn abstract descriptions into concrete rules, the solution becomes a matter of following a sequence. Take this rectangle with a length of 8 inches and a width of 5 inches. To find the perimeter, we calculate the total distance around the edge. Adding 8, 5, 8, and 5 gives us 26 inches. The perimeter is just that one-dimensional border. The area, however, is the two-dimensional space inside. We find this by multiplying the length of 8 by the width of 5, which equals 40. Pay close attention to the units. Perimeter is measured in linear inches. Because area involves multiplying inches by inches, the result is 40 square inches. Correctly identifying whether a problem focuses on the border or the capacity prevents the foundational errors that derail most solutions. These rules become even more efficient when we look at squares, where every side is the same length. If a square has a side length of 7 inches, the area is simply 7 squared, or 49 square inches. The perimeter is 4 times 7, giving us 28 inches. Because of this symmetry, we can use these side length shortcuts to solve for both area and perimeter with a single variable. Circles introduce curves into the mix. If we are given the total width across a circle, we have the diameter. In this case, it's 8 centimeters. Formulas for circles rely on the radius, not the diameter. Before you calculate anything, you must cut that diameter in half to find the distance from the center to the edge. Half of 8 gives us a radius of 4. Now we can find the area using pi times r squared. 4 squared is 16, resulting in 16 pi square centimeters. For the circumference, which is the perimeter of the circle, we use 2 times pi times r, giving us 8 pi centimeters. Always establish the center point and radius first. This ensures you are using the correct spatial reference before applying your formulas. We can also work backward. If we know the total perimeter of a square is 60 centimeters, we can find its area. Since the perimeter is 4 times the side length, we set 4s equal to 60. To find one side, we divide by 4. This tells us each side is 15 centimeters. Now we move that 15 into our area formula. 15 squared is 225. Meaning our square covers 225 square centimeters. This proves that these equations are two-way streets. If you have the boundary, you can reconstruct the entire shape. Let's apply this logic to the word problem we looked at earlier. First, we translate the words into symbols. The length is L. Is means equals. 3 more is 3 plus, and twice the width is 2W. We have our first relationship. L equals 3 plus 2W. Next, we incorporate the area. We are told the area is 90. Since area is length times width, we write 90 equals L times W. We can now replace the L in our area equation with the expression 3 plus 2W. This gives us one equation with one variable. 90 equals 3 plus 2W, all multiplied by W. Distributing the W gives us 3W plus 2W squared. To solve this quadratic equation, we move the 90 to the other side to get 2W squared plus 3W minus 90 equals 0. To factor this, we need numbers that multiply to negative 180 and add to 3. Those numbers are 15 and negative 12. By splitting the middle term and factoring by grouping, we find two possible values for W, 6 and negative 7.5. Since a shape cannot have a negative width, W must be 6 centimeters. With a width of 6, we divide the area of 90 by 6 to find a length of 15. Finally, we calculate the perimeter. 2 times 15 plus 2 times 6 equals 42 centimeters. Solving advanced geometry is a process of converting descriptions into substitutions. We've moved from an abstract paragraph of text to a fully realized, quantifiable shape. By defining the boundaries, managing the radius, and using substitution, you've broken down a complex scenario into simple steps. Any mathematical problem can be dismantled this way. When you use the foundational rules systematically, the solution becomes inevitable.